Hey guys, James Austin, Josh Hosford here with Jackson Metal Roofing Supply. We're going to be talking about some things today related to your steel truss post frame structure that you would be getting from us. What we have here is a copy of the engineered drawings laying out the truss, laying out the pier system. Now Josh is going to speak to the importance of that from the engineering standpoint. What I'm going to speak to is from the initial point of your project. You would need this drawing right here to take to your building county inspector to verify what you're getting ready to build is going to fit in your area. Number two, it's just going to give you some overall information about the integrity of the building you're getting. Is it going to do what you're looking to do with it? Now, if you're like me, I'm not an engineer, and before I got into this business, I didn't really understand all this stuff. Josh is going to clean that up for you, but also the sales staff here at Jackson Metal is trained. They've reviewed this. We can answer any of your questions regarding engineering of your post frame structure. So with that, Josh, would you take us through what this drawing means to the customer and us?
Okay, so James, what we're gonna have here is, first off, you see the design criteria.
Yes.
This thing is gonna list the wind load, it's gonna list the live load, the dead load, snow load, and the concrete requirements in order for this to be installed properly, which this is the concrete requirement here. Now, so for most of these first four items, the typical consumer, this is not anything that they can alter. That's one of the advantages of dealing with this steel truss type of system. This is all prefabricated, it's pre-welded, everything is ready to go. The only thing that'll be assembled is they'll be attaching the two halves out here in the field, assembling those and putting in this wind brace right here. Other than that, the only things that can be altered by the typical consumer, contractor, installer is going to be the concrete foundational pier system. And that's what we're going to actually be addressing today, the different types, what does this mean, and how to read what's actually happening here. So this is going to be detail 5. If you look down, detail 5 indicates it's the concrete. That concrete is going to be 3,500 PSI. So that's 3,500 pounds per square inch is what this is going to be, compression strength. So that indicates that this total pier right here should be dug out and be 3,500 PSI backfilled with concrete. Okay. So you say to me, how do I know the size of this pier? Well, that's very simple. We'll look at detail 5 right here. So you have several numbers in here indicating what each of these components are. That is going to refer to the legend over here. So number 5, that's going to be a 6x6 pressure treated wood post. The next thing is going to be number 8. So you look at number 8, that's an 18-inch diameter by 36-inch deep foundational pier, okay? And then number 9, lastly, is going to indicate it's a number 5 rebar, 12 inches long. Okay. So when we look over here and we look at the number 8 requirement, that's going to be 3,500 PSI, 18 inches by 36 inches deep is what this is indicating right here. 18 inches in diameter, 36 inches in depth. Okay. So when this system right here is augered out, they will excavate the full 18 by 36 of dirt out. It will pack the bottom right here, pack the bottom in hard, and then at that point in time, this post would be entered into the system right here, into the hole, and braced off up top to be plumb both ways, plumb and level. Okay. This 12-inch rebar would be inserted through the 6x6 post and will also connect out into the concrete. It'll extend into the 3,500 PSI concrete so that all this becomes one solid system after the 3,500 PSI concrete is poured into this foundational footer. So this right here would be the typical detail of this particular type of structure. This is how this will need to be done in the field. Okay. Here in a little bit, we'll be going through some real world applications so that we can actually see what does that look like, not on paper, but in reality.
Got you. So what you're telling me is having these two things in combination, a quality product truss that meets engineering, must also have the proper foundation for that system to work together and give the end user a good product.
That's exactly right, James. So for any structure, The core integrity of any structure, any house, any building is the foundation. Without a good solid foundation, you don't have a good solid structure.